This video shows you how to model the building in the picture. You will learn how to use curve interference geometry in Sverchok. Now let's go back to Sverchok. First you need a hexagonal mesh object. Sverchok already has a node like this built in. Allows you to quickly generate polygon collection meshes. Next, each face of the mesh is offset. Later we need to interfere with this offset value. We do not need to generate interpolated faces for this model. Again, use a field to define the spatial variation. The edge mode will use the edges of the polygon to generate the field. Here, we need to define a curve. The curve mapping node can also output a curve. As you can see, the generated curve is too small. So we need to reset the range. Adjust a suitable curve shape with the preview. Convert this curve to polygon geometry for input to the attraction field. Now we have a field defined by a curve. Use the scalar field evaluation node to obtain the value of the point in the field. The points here need to be representative of the spatial location of each face. So I use the analysis node to get the midpoint of each face. Enter the resulting values into the parameters that need to be disturbed. This value is obviously too large. We can remap the range using the value mapping node. Now you can still go back to changing the shape of the curve before, to get a disturbing effect that you are happy with. Again, we can apply it to the offset. This concludes our interference section. To make the model less flat, I will distort it using the deformation node. First, use a noise wave deformation before the offset. Let it distort in the z-axis. And use the matrix to set a reasonable distortion space. And then use the simple deformation node to make it wrap around the deformation. Here we need to set a correct distortion space using the matrix. The geometry is now interesting enough. Finally, the building is completed by applying a solidification.